Hello everyone, this is Christine for Project Miar, INF 490 Fall 2018. This is to fulfill the 10 to 15 minute video presentation for our capstone seminar in informatics. Without further ado, let's begin.
Deep Learning Object Detection API using convolutional neural networks is what Project Miar is based on. Let's take a look at the convolutional neural networks. Here's a picture here. Convolutional layers are networks are made up of three parameters: a convolutional layer, which applies a specified number of convolutional filters to the image, and each subregion performs a set of mathematical operations to produce a single value in the output feature map, which will be an example of my GitHub. You'll see my label map. It'll say item and name of that, and that's my feature map for the project. The second layer is the pooling layers, which is the downsample from the image data extracted by the convolutional layers to reduce the dimensionality of the feature map in order to decrease production time. And then the third layer is a dense, fully connected layers, which actually performs the classification of the features extracted and downsampled by the pooling layers. In the dense layer, every node in the layer is connected to every node in the preceding layer. So at the bottom of the screen, you'll notice that.
As you can see here, the screen, the image recognition is recognizing me as a 92% accuracy as a person. It has over 90 classifications, one of them being neuromote, and each classification will have a different percentage as far as what the camera can recognize. Computer can recognize, so we got a 93% that this is a remote. And I have a cell phone. So let's probably find right there. So it's kind of sure, I guess because I don't have the whole thing. Let's find the cameras. There we go. Okay. And this is just a brief example of how the project's going to work. My project will be trained to recognize facial paralysis in patients. So instead of a person, it'll say stroke. The initial plan was to have that basically recognize three areas of the face. So up here would be droopiness of the eye, the cheek, and of course the mouth. Just basically symptoms of facial paralysis for stroke individuals that would alert an emergency system, but that was not included in this project.
Our brains are able to recognize objects like this is a cat and this is a dog. It doesn't need hundreds of images of them to recognize it. We can just automatically know through features like their ears, the way they move, their different types of noses, things like that. In machine learning, it's a little different. The computer doesn't know right away that these are a cat or a dog. It has to be trained, and that's part of what this project does, is train the model to recognize symptoms in stroke to hopefully help people get to the hospital faster by that indication. Here we can see TensorFlow's three-layer neural network. This data flow programming is a programming paradigm directed at a graph. So we can see that through principles in architecture and programming languages, we're able to develop a functional concept through numerical processing, and they go through different gradients and different filters through the program to come out to the final output. Every 40 seconds, someone has a stroke, and every 4 minutes, someone dies from one. There are two main types of strokes: ischemic and hemorrhagic. An ischemic stroke blocks blood flow to the brain, usually fatty tissue. No oxygen to the brain means blood cells die within just a couple of seconds. 87% of strokes are ischemic, while hemorrhagic strokes are bleeding in the brain from a ruptured blood vessel. Symptoms of the stroke include facial paralysis, arm weakness, speech difficulties, and time. The sooner you get help, the less severe your symptoms are. We're focusing on facial paralysis in this program. There are three main areas that I have trained my model to look at, and that is the droopiness of the eye, which is pulled down by the weight of the droopiness of the cheek, and your mouth leaned in.
Here's an example of my machine in training. It's been training for some time now. I've stopped and started it. As you can see here, what we're looking at is the total loss. So anything under 2, you're going to get a pretty fair accuracy for your image detection or object detection. Some people do animals or a cup. But specifically, I'm getting around 1.8, 1.74. These are good numbers for the model that I'm using. So I'm going to kind of bring you in here to my folders. So this will take a while, so I can scroll up so you guys can kind of take a look and see where my loss is. I started, I think, around an 8 or a 9, so the model's been training over and over to this point where it's getting down to a pretty good accuracy. So in here, we're going to kind of take a look at my folders and see what exactly we have going on. So the first thing that I did for my project was download Anaconda for the utilization of the models. And it's been pretty fair to use. I think you can kind of see this here. I have for my TensorBoard graph, so you'll see that in the presentation, along with a short clip of how I'm training again. And then one of the first steps that we had to do once we have our images annotated is we need to convert the XML files to CSV, and I'll kind of share that with you guys, what the code entails for that. So here you can see an example of that, and importing pandas. This was one of our dependencies that we needed to have, and these are kind of our parameters for this project. And then once we have our files in a CSV format, we're going to need to generate those in a TF record format, which is what TensorFlow can read, and that's through our generate TFR record file there. So I'll open that up so you guys can take a look at that. I've already processed all of these and kind of have my files for that, but here's the code for that. I have my label map. I kind of mentioned that this is just a simple project. So here, move it into the screen a little bit. Yeah, it just has your item and your ID number. This is how the machine is able to label what you're training it on. And then if we look down here, I have my image detection folder, and I actually have that open already, so I'll pull that up because it takes a minute to pull up the machine. But once I run this code, my webcam can detect and read the code that I had trained the model for. So I'll close out of that. And I have an image pulled up on my other laptop, so we can kind of take, let's start this. So we're getting a 99% accuracy. My machine's having a hard time with the frame of my laptop. I haven't classified that in this specific model. I really wanted to focus in on the stroke. So as you can see, the different areas of the face that are affected by that. But a 99% accuracy is something that could be a reliable parameter and reliable accuracy for a future model. Here's an example of my machine in training. I hope you guys have liked this video presentation of my project, and I hope that it inspires you guys to do one of your own. Hopefully in the future I can use a little bit more specific or faster convoluted networks to recognize a little bit more detailed analysis of the face. And even speech recognition project would be improvements to this project. Several challenges, including installation and figuring out which updated versions went with other versions, really complicated the system. And working with Windows, of course, is always going to cause some kind of challenge for installing dependencies on your machine. But otherwise, that's it.